How's it going, everyone? Welcome back to the next episode in which we discuss some of the questions that have been the most upvoted or commented on the previous week. And of course, all of these are just my opinions based on my experience. If you have seen something different or disagree with some of my opinions or even have further questions, don't hesitate to reach out to me on LinkedIn by leaving me a message or a comment on YouTube or simply explaining to me what might be different. Again, there is no shame in learning more in our industry. There's always some interesting perspectives that might be brought up. So I do not take offense to anyone disagreeing and basically explaining their point of view, as a lot of these questions are, of course, nuanced. So let's switch over to the first question, and it comes from the username by Mayo Does, and he's saying, is there any way to prevent IP theft as an integrator? And he says, I work as an integrator, mostly doing OEM work. A customer that has contracted me to build multiple machines has approached me to build more. However, have told me that I need to offer at a better price due to India underbidding. I am unsure the conditions at this time, but what I can do to prevent my design and PLC HMI code to be used by others to copy the panel that I made. They are expecting me to hand over a completed set of drawings and source code for machine when the current job is over. In my head, I relate to this just because you bought one seat of Windows 11 doesn't give you the legal permission to install it on 20 more machines. And so this is a common problem in our industry. If you have not experienced this for yourself, it definitely is something that will happen. And so the question often becomes, when you are designing the first piece of equipment, it could be just a simple machine, just like it could be an entire production line. Who does the code ultimately belong to? And of course, the answer is going to come down to the legal documents and the agreements that you have signed, but there's also the moral question as to what you can charge and what you can put the end user through as they are deciding to create and, I guess, support some of the equipment that they are building. It is a very difficult question to answer, right? And of course, there's going to be nuances on both sides. I have certainly been in situations as the end user where an integrator has completely locked down their code, and the only path forward was you either pay for the software or you reverse engineer the software in order to have your own copy as the end user to then be able to replicate, as he described, onto other equipment. Of course, the third alternative would be to bring in a different party that can also reverse engineer the system, create their code. So ultimately, the question becomes, who does the software or the intellectual property or the IP belong to? So like I said, the short answer is, of course, there's going to be legal documents. And here's my general perspective. The end user, at the end of the day, is paying for two different things when you sign a systems integration agreement. In a lot of cases, they are purchasing your time and materials, or T&M, so that you develop a project for the system that they will then receive. And so, generally speaking, they should have ownership of the work that you have produced during those specific hours. However, and this is where the nuance comes in, if you have developed or had to develop something in your own time in order to make the system function, I believe that that component should become your company's or the SI's intellectual property. Now, of course, where those lines are going to be in the real world is going to be up for debate, and people will have different opinions. However, it is my opinion, if you're going to bill for, let's say, 40 hours a week, and you're going to spend 10 weeks to deliver that specific machine, and you have only worked within the confines of the billable hours to start the code from scratch, you have not built any intellectual property because the customer has paid for your time. However, if you bring with, or you come in with templates, you come in with functions, you come in with designs that have not existed before the start of the project that allow you to shorten that time, meaning that instead of 10 weeks, now you're taking maybe 8 weeks or 6 weeks as a result of you having created intellectual property to be used for that project, that is going to be or should be protected, in my opinion, as you have not charged that specific customer to develop that IP. Now, in this case, he has described that he has been contracted to build multiple machines and has approached me to build more. I can only assume, since he hasn't mentioned that there was any IP prior to developing these machines, that the customer has paid him to do a project end to end, meaning that no code existed at the beginning and a final version now exists on the machine. And so the question then becomes, who does the code belong to? And generally speaking, again, without further details, without any legal contracts, I would say that the customer now owns the code. And of course, at this point, this systems integrator is in a difficult position where he needs to be bidding against a different company that is going to take that code and potentially deliver a similar result. Now, I have been in many of these projects, and to be honest with you, if you have built a good relationship with this end user, he should have a preference for your services as opposed to some other random company. And unless there is some maybe tension or a very severe difference in the bids, I don't see why he would go with somebody new when he has already someone that has built multiple machines and is capable of producing more at the specified rate. So I would be, again, extremely hesitant because I think that the end user is going to put themselves in a very difficult position by negotiating themselves out of the basically work that could be done a lot better, again, based on my general understanding here. And of course, the end user, right? So he probably has pressure from the executives. It could be VPs, it could be C-suite, to purchase equipment at a lower price. Therefore, if you're going to design code for new machines or new equipment at a lower rate, you do have some incentive on going with the lowest bidder when it comes to the design. So my general advice is, in this specific scenario, I believe that the end user owns the code. However, as you are the originator of that specific code, you should be very clear with them that the value you bring is far more tangible than bringing in some other random third party that is going to take a lot of time to reverse engineer the code, create potentially something very different than what originally intended, and they will probably spend more time trying to, again, build the knowledge, but also make sure that the new machines are running as expected. The second question is very interesting, very broad, I would say more philosophical than anything else. So the user by the name of Shub is asking, what's the biggest difference between a good PLC programmer and a great one? And he's saying, not talking about years of experience or specific platforms, when you've worked with people who really stood out, what separated them from everybody else? Was it troubleshooting ability, system understanding, documentation, commissioning experience, or something else? And again, this is where maybe I can tell one of the stories where I was truly impressed by an individual that worked with me on knitting a system that I had originally designed. He reviewed the design and then helped me go through, once again, the commissioning process with the end user. I was impressed by a couple of things. Number one, I really liked the tools that they were using at the time. So what I originally discredited is the use case of MacBooks or Macs in general inside of our industry. And this is 2018, so we still have the Intel Silicon, which made it very easy to install a software called Parallels, which then allowed you to any basically like software and run it on a Mac. This specific engineer had all the virtual machines at the time, and I still remember how much faster he was at basically opening any different version. We were working with a variety of different systems. This was a large commissioning project, so he was just flying through some of those specifications based on the hardware he had brought to the project and was able to leverage, again, OS and hardware that I believe is still superior. Obviously, it is a lot more expensive, and there could be arguments made Windows versus Mac, but ultimately, I was impressed by the hardware he had brought to the project. There were also some other differences. I remember learning from him the wireless setup for PLCs, and this is going to be a separate video that I'm looking to make on the channel, so stay tuned. But ultimately, he was very efficient at his job by utilizing the appropriate tools that at the time I had not been exposed to. The second item is, of course, resourcefulness. So as I work with engineers who are a notch above what I would call good, they are able to not only resolve their own issues inside of PLC code and programs and hardware, they're also able to pull other resources with questions as needed. And what I generally mean by that is, let's say you have an issue with a power flex drive, for example, during a commissioning process. You can obviously spend a lot of time going through the code. You can then pull out the documentation. You can look at the parameters. Then you start reading your tech notes, right? So this is going to be a Rockwell system. So if you have access to Tech Connect, you might be able to find some information. However, the next step would be to contact either peers or experts that you have made at trade shows. If you have contacts inside of the industry, those are extremely valuable. And so a great, I would say, PLC programmer is not only sitting in front of the PLC program and trying to brute force a solution, they are very resourceful in terms of people they can reach out to, contacts that they have had in the past, colleagues, peers, etc., etc. The last item, of course, I would make is he mentioned not the years of experience or specific platforms, but I would say it's the breadth of knowledge inside of our industry. And I think it is very difficult and does take some years to understand, but a person that is curious about more than just the automation side is usually going to differentiate or be the factor between a good and a great PLC programmer, because it is, in my opinion, it is the fundamental step to know how to program your PLC and how to work with the platform and all of those technical details on the automation side. It takes you a step above to know the industry, understand the process, whether that's chemicals, oil and gas, water, wastewater. Obviously, some of them are going to be a little bit easier to understand than others, but having that curiosity, asking those questions even in meetings when you're discussing with the customer, it is extremely important. Hi, my name is Vladimir Romanov. I am the founder of Joltech as well as Solus PLC. With a background in electrical engineering and MBA and over a decade of experience leading projects in manufacturing and industrial automation, I help engineers, managers, and manufacturers make smarter technical and business decisions, modernize their operations, and build stronger careers. If you're serious about manufacturing, automation, and staying ahead in the industry, subscribe and join the community. The next question is absolutely something that we need to discuss, and it comes from the user by the name 13. And he's got a question around the legitimacy of the hardware that he has received. We see a picture with a factory seal and, of course, a second one with the listing for the catalog number, as well as the standard firmware, the description of the module, and the general or regular, I would say, label from Rockwell Automation or Allen-Bradley. And the module, of course, I had already read through the comments and recognized some of the issues with this, but I still wanted to discuss and give some of my thoughts on the hardware and the state of our industry based on the fake or illegitimate hardware. So, number one, if you haven't dealt with this before, what you will realize is that there is going to be counterfeits in our industry that will generally sell for much less than legitimate hardware. And of course, a lot of this hardware comes from other regions of the world, from China primarily. And if you go on eBay, you will be able to find good deals on hardware that comes from those regions for this specific reason. I have personally never purchased illegitimate hardware, therefore I have never ran into these problems, and I could not say or comment on the fact whether or not this is actually going to work, or if it's going to be a dud, or it simply isn't going to last as long as proper hardware. That being said, you also have the product ID that you can input into the Rockwell website, where you can see whether or not this hardware is legitimate. So it is easy to check. And the same comment goes for almost every vendor. If you go on their website, if you create a portal with them, or if you're working with a distributor, you can generally check whether or not the hardware is coming from a source that is legitimate. That being said, if you receive this as part of you purchasing hardware, again, it could be eBay, it could be some auction sites. Of course, if you're paying a tenth of the price or even a 20th of the price, chances are this hardware is going to be fake. And there's going to be a few, if you spend some time, you will find clues as to why this looks incorrect. A lot of times it's going to be based on the label, sometimes it's going to be based on the packaging. Once you open the piece of hardware, there's also going to be different signs as to what is on the label of the actual either PLC or IO card, like it is in this case. And of course, I understand that there is some reasoning behind saving some capital behind purchasing illegitimate hardware that might be discounted quite a bit. Again, my approach and my comment would generally be, if you need something that is reliable, you should be always going through your distributor or through the OEM, purchasing the right hardware. Maybe you will save a little bit of capital, but you will typically burn the number one, the relationship once they find out this is the route that you're going. You will also, again, risk some legal action, I would assume, if you're doing this for a production environment. Obviously, if you're maybe learning on your own as a student, there's not going to be a whole lot of harm. But again, in the worst case scenario, you will just, or I would say in the best case scenario, you will just would have paid for something that isn't going to work as it should, and you're going to have to either process a return or make a claim on eBay or some other platform. So you would have wasted just a lot of time. This is a great question, and I do have a brief story on this front, so we're going to switch over. This question comes from the user by the name Call Simja, and he says, what's the most expensive lesson you've learned from a cost-saving decision? I've been on projects where we spend weeks debating ways to save a few $100s on hardware, only to burn thousands in engineering time later. Not saying that cheaper is always worse. Sometimes it absolutely makes sense, but sometimes a decision that looks great on the bill of materials ends up becoming expensive somewhere else. What's the biggest example you've seen where trying to save money early ended up costing more later? And this is a prime example. I'm actually going to remove my downvote, as it is a prime example of what I try to have a conversation about with every single customer, because I would say the allure of saving the hardware capital and the software capital up front is extremely high, because then you can reduce the cost of your project and you can demonstrate to everyone that you've been able to achieve something at a much cheaper rate than anyone else could have otherwise accomplished. And the extreme example here, right? So in the industrial automation space, you often see largest companies with the top two brands in our space, right? That's going to be Rockwell and Siemens. And then depending on the manufacturer, you're going to have an array of different other alternative solutions. And that's going to be, again, your Opto 22s, your PLC Next from Phoenix Contact. It's going to be your Backoff, B&R. And there's a variety of different options outside of the control systems that you could get into. So you could be looking at different drives, vision systems, load scales, different sensors, right? So there's going to be a ton of different options. And of course, everyone, when you're looking at the bill of materials, is trying to ask the question as to why we are deciding to go with one of the most expensive brands as opposed to an alternative that many can go online and find a price is significantly less expensive than the leading providers, right? And of course, the answer there is that you have not considered the long-term cost of going with a different solution. And it's not to say that the solution is worse on the technical side. It is also important to consider factors that may be outside of the PLC itself or the peripherals that will be used inside of the control system. It could be the relationship with the OEM, the fact that they are able to support you in your region, and should anything fail, they will send you that component replacement within 4 hours instead of 4 weeks, like some of the alternatives. It could also be hiring the people in that region that already have that skill set because there is a local college that uses that specific brand, as opposed to hiring someone and having them spend 3 months or however long to ramp up to the platform that you have selected. And of course, there's going to be different nuances and different discussions to be had around that, but it is always an important reminder but that just saving on the hardware doesn't necessarily mean that you have saved the cost overall. And so the example that I want to bring up is I worked for a fairly large end user which had purchased a machine with a very specific set of components. It was actually a printed circuit board, right? So imagine a printed circuit board with a specialized controller that was programmed by a company in Michigan to apply labels basically to packaging. And that specific printed circuit board would interface a Parker servo. And so the problem that the end user we ran into was the fact that instead of being able to troubleshoot the system, everyone would just swap out all the parts, right? So you would go back to that company and you would purchase one of the three, and that was the printed circuit board, that was the HMI, and the servo drive that needed to have very high precision on applying those labels. And of course, over the years, yes, you have purchased a much cheaper label quote unquote applicator, but you have spent quite a bit of time because of the inability to troubleshoot that specific system. And you had two options: either to reverse engineer the solution, you had to or keep running the equipment and obviously incurring ongoing costs. Again, the servo drives don't fail very frequently, but just a naked printed circuit board inside of a machine in a fairly dusty and high vibration environment is going to fail on a semi-regular basis. And so what ended up happening is that a lot of investment was made to retrofit that machine with Rockwell automation or Allen-Bradley control systems. I still remember that we gutted all of it completely. We put in a remote I/O coming off the main control Logix PLC, along with, at the time, it was on Circos, so it was a 6200 series drive. At this point, it might be a Kinetics 55 or 5700 series. So again, on Ethernet, but at the time it was on Circos, and so we gutted the entire machine. We replaced it with our own control systems. Everyone knew how to troubleshoot that side, and of course saved a ton of money in any eventual failures or issues with that machine. This is a great question. I have actually recently rejoined ISA and I am part of the local chapter here in Montreal, Canada. So I do have a couple of comments based on the general, I would say, set of standards in our industry. I am not as familiar with the question standard that is being pulled up here. Let's take a look. So the username by Nervous Wrangler 756, high performance, my thoughts. What are your opinions regarding IN1? Do your clients appreciate it? How do your HMI and SCADA screens differ from the standard? I'll go first. We typically substitute a PNID type diagram for the process overview display rather than an level 1 and 2. So as I've mentioned, as a very brief disclaimer, I am not extremely familiar. I have not read through IN1. I have seen multiple pieces of content around high performance HMI. You can find a variety of different videos on YouTube as to what this actually entails. I will not be pulling up the standard on the screen either. It is something that you will need to pay for if you would like to subscribe to ISA and then have access to. So again, what is my general opinion? I have been fairly particular as to the design of HMI screens because I have learned from a mentor of mine which is incredibly talented and had almost, I believe, 35 years in the field when we had originally discussed and he had explained to me how to design HMIs properly. He has not used or has not taught me based on ISA 101. It is not building minimalistic screens. It is understanding the design that your customer wants to use and is usable for the specific application. So I do believe that ISA definitely serves a purpose, but it is not not an end-all, be-all based on what I have seen. I still do likes to have some indication when you have piping, when you have elements that need to be animated, but it does not need to be excessive, right? So there is some kind of a middle ground I would hope that we all agree on, that maybe ISA 101 and just high performance minimalistic HMIs is not what most customers prefer, but there is this middle ground where you have some elements from ISA and then some elements that do make some other, I would say, serve some other purpose that make more sense for specific industries and or customers. And again, I believe that there is an element of preference, but there also is an element where you as the HMI designer need to educate the customer on what is ultimately better, that you cannot simply recreate the screen that you had maybe in Panel Builder 32, right? So very old type of software. You want to migrate that over to Factory Talk View ME or SC or even Ignition, and you're going to give them a very different feel that should improve the HMI as a whole. The last question that we will tackle today relates to a very common problem when it comes to the general industrial automation, I would say, industry. So let's switch over and take a look. So this comes from a username by the name of Uptown Soul. He says, how to find a usable IP address to connect to a PLC network. Hi, I need to connect to a PLC, but there is no documentation in which IP address range to use for my PC. The PLC has several EN2T cards, but I'm assuming the local PLC network is 192.168.1.mask. By checking the backup, how can I select an IP without duplicating it on the network? It is a L72S. So I certainly have a lot of experience on this front, and I do have a couple of thoughts and I would say a few pointers for when you find yourself in this specific situation. So number one, when you are looking at a control logics, whether that's the safety variation or just the standard PLC, as he mentioned, he should be able to see the Ethernet mask scrolling through the PLC or the EN2 card that's going to be within that rack. So he should be able to identify first and foremost the PLC and the cards that are on that specific chassis. Before I do anything, I would first of all double check where are all of those devices going. Is that going local? Is that going to the plant network? And establish where it is that I am going to connect from. If there are multiple cards, so he says there's several, so we would assume that there's at least two of them. In good faith, we can assume that both of those cards are not on the same network. Therefore, there is probably a private network and a plant network. So if you're going to plug in on the private side, generally speaking, you will have a lot less devices, again, depending on the configuration, of course, of the rack and the entire system, as opposed to the plant. So on the plant side, I would speak to, right, so if they have a plant level switch, typically someone should know and be able to tell which IP addresses have been assigned, which VLANs have been assigned. I have a long discussion and full course on IT and OT networks, but IT is going to be your friend when it comes to plant networks. They should be able to give you a full map of different IP addresses and provide you with an IP address for your computer to plug in. If you're on the control system side, again, first of all, that network should be limited. You should start by talking to the engineers or technicians on the OT side. You should be reviewing the drawings inside of that panel, which should typically indicate where those cables land. And in most cases, I don't want to say in all cases, but in general sense, have an IP label for every device that is going to be connected to the switch inside of that control system loop. Now, of course, if you're completely unable to find an IP address, there's going to be other ways to validate. First and foremost, if there's pressure of delivering this system or change or making a change, connecting, I would opt out for going or opt in for going with the HMI route. So that PLC as well as the ET card should have a USB port through which you can connect. You can go through the backplane and you can connect and obviously go online with the PLC. The following steps, of course, then it becomes a question, can we bring the system down? Can we disconnect one of the Ethernet ports, or do we need it running? And of course, if we need it running, then you are getting into packet sniffing territory. So you can basically install Wireshark and start trying to understand what packets are being sent while potentially having a conflict of IP addresses. Of course, this could bring down your system. It is not the first step that I would recommend. Be very careful in doing so. Make sure to document the risk. But at this point, we are, I would say, setting our IP address to DHCP, which if there is a router on that specific, or I guess if there is a gateway, there might be some addresses given by a DHCP server, which is extremely rare on the OT side. So probably on the plant side, that might be the case. I would take down the IP address that is given to us, and then I would start looking for the switches that are going to be closer to that PLC rack. And so if it's the Stratix platform like I have behind me here, you can, once again, if you can figure out the IP address of the switch or the gateway, sometimes someone will leave a label on the physical device. You can then go inside of the interface. Again, there's a lot of ifs, but if you have the login information, you can start looking at the IP addresses, you can start looking at the ranges, you can choose something perhaps that is on the safer side and try and see if that works. If not, there's going to be other means of sniffing out the traffic via Wireshark, as I've mentioned. And of course, if all else fails, you have the option of disconnecting the control system from the plant floor, assigning an IP address that is in the same subnet as displayed by the EN2 card, and then connecting by the direct your laptop to the RJ485 basically card and going online with the PLC. I did look at the comments and there was an interesting point on that last question, which is to look at the HMI. So a lot of times if you're working with Rockwell, with Siemens, or many other providers, you can see the IP address of the HMI. And why is that important? Usually HMIs, in most cases, again, that may not always be the case, but HMIs are just quote unquote thin or dumb terminals, meaning that they do not run any logic. They're just the interface between the screen and the PLC. So what that means for you as the programmer, you can find the IP address of the HMI, you can disconnect the HMI, plug in, go online, look at the IP addresses on that network, but you are certain that IP has been assigned and is working to communicate to the PLC. Therefore, once disconnected, it should become available for your specific use case. I think that is a clever approach. I had not had to do that kind of way, so I have learned something new today as well.